Okay, Math 30-2s. We're going to go over assignment number 1 here of our logarithms. Let's see how well you did. Okay, so we are going to create some graphs here. The reason I put the graphs here is more for the end behaviors than anything else, because everything else just stays the same. But this is a nice positive logarithm. Okay, so I'm drawing a positive logarithm. It's going to go upwards like that direction. Again, this is another positive one, but this one here, because of the 2, it's going to go upwards a little bit faster. I'm not really too concerned about what the actual shape looks like here. Because this is negative, it's going to go down this direction. And because this is just a regular one, this is base 2. It's positive as well. It's going to go up. Okay. I'm not too concerned too much about what the graph looks like precisely. It probably doesn't look exactly like this. Maybe it looks a little bit more flat. That's fine. I'm okay with that. Okay, so the domain for all of these are the same because that's just the way this course is. Oh no, okay. It's going to be greater than 0, XER. Let me just get rid of this here first. Okay, so all of these, all the way across, are going to be the same. Our range is going to be the same for all of these because that's just the way this course is as well. Going all the way there. Okay, coordinates of the x-intercepts. So my x-intercepts, because it says coordinates this time, I'm actually going to put a coordinate point here, 1, 0. And my y-intercept is none. There we go. Okay. And my end behaviors. So the end behaviors are slightly different. The only one that's actually different is that second one there, or third one, sorry, because it's a negative behavior. But this one's going from quadrant 4 to quadrant 1. I don't know why I drew it like that. I just did. Okay. HEI. This one's doing the same thing, quadrant 4 to quadrant 1. And this one here, though, because it's negative, looks more like it's going from quadrant 1 to quadrant 4. Because it's going downwards there. And this one's going from quadrant 4 to quadrant 1 again. Nice positive one. Cool. Okay. Let's go down here and look at these. I just want to double check that. Yeah, that looks pretty good. Write these equations in logarithmic form. Okay, so they just wanted us to change this, maybe like solve for x. They want to know what x is equal to in this situation. So it's log base 5, and now it's going to be a y there. And this one here, they want to know what y is equal to. So they're going to drop that y down. Same thing, they're going to drop that x down. Log base 75 of x. There you go. We're going to do the same thing here. We're going to draw these in exponential form this time. You can kind of do like a 7, but the y's on the odd side there. But it's the same idea what you did before. You're just going to kind of switch those. So it's like you try to solve for x. So you're going to pop the x out of it, do the inverse. And the base of this, because you don't see a base there, you assume that's a base 10 to the power of y. And this one here, the x pops out as well. But this one, they give you the base of 2. They tell you the base is 2 there to the power of y. There you go. Students asked to find the value without using technology. Explain how he can do this. So trying to figure out how can I solve this is I'm going to draw this as exponential form instead. Okay. So if I were to go exponential form, you could draw like a little 7. So you could put like a little y over here if you want to instead. So starting with the 3, go up to here and then go across. So this would be 3 to the power of y is equal to 729. So this is how I would start this and say, okay, 3 to the power of y. So 3 to the power of y is 720. So if I didn't have my technology in front of me, I would look at my chart, okay? And I would just try to find out what value would I put in my exponent there to make sure that I get 729, right? So there's a few, you can create some kind of factor table here of all the different factors of 729. What you'll realize is 729 is the same as 3 to the power of 6. So it means y is equal to 6, right? showing all the steps and the correct answer. So you could explain it. So like I would say here, I would convert to exponential form. And then figure out what exponent is needed to get 729. Right? So that's what I would do. Okay, sounds pretty good. This one here, it's going to do kind of the same thing as that question, but this time I'm not going to explain what I'm doing. I'm just going to just do it. So here's my base is 10. So if you don't see it, remember your base is 10. So 10 to the power of 5 is equal to x. That's 100,000. There you go. X is equal to 100,000. Okay. So this one here, same idea. This is going to be x to the power of 3 is equal to 64. So to figure this out, I'm going to take the cubed root of both sides. So what is the cubed root of 64? I don't know. Let me just double check. It's 4. So x is equal to 4. Okay. This one here is going to be 2 to the power of negative 2 is equal to x. 2 to the power of negative 2 is 1 over 2 squared, which is 1/4. You can just plug that in your calculator to get 1/4 as well. This one here, just remember that this is going to switch the spots here. So this is going to be 4 to the 5 is equal to 4 to the x. Oh, x has to be 5. It just kind of makes sense. You just drop the base like we did in the last chapter. And these ones here, you're just going to try to match these up. So let's see. So I'm adding 2 logs that have the same base. I'd multiply what's inside. So that looks like this one down here. So I would say that this is a. Okay. Yeah. Okay. I'm subtracting them. So I'd be dividing them. So that looks like this one here. This one has a problem. This one has a c in the front. So what I'm going to have to do with that c is raise it up as an exponent. It's going to be kind of weird to do. No, that's just going to maybe mess up both those things. Let me just fix this. Oh yeah, okay. To fix it, I just have to change the way it looks here. Good. Okay. Oh, I want to go pen. Oh, how can I do that? There we go. Pen, delete. Let's get rid of that there. Okay. So this exponent here is going to go up here. So this can become log base b a to the c, then log base b of b. Okay, now I can multiply these two things together, and that looks like it's going to be c in this one. Okay, so this one here, I'd go first of all, I would divide these two, then multiply by c. So that's going to be d here. Okay. This one here, oh, it's a change of base formula. So remember when I take a log and divide it by another log, this turns into this. Now, remember when you do this, it's usually base 10. The 10 just disappears, really. So this is a new log like this one here. Okay. And this is times, times, times. That's an easy one. Because plus, plus, plus turns to times, times, times. And there we go. All right. Hopefully you guys did pretty good. And we'll see you in the next video. Bye.